Hey Adrian, hope you had a good weekend, or having a good weekend when you see this. Thanks for covering for me on Monday and then also again on Wednesday. Um, yeah, let's get started here. So, Integrated Math 1, here's what we worked on last Thursday and Friday. I had the students working on reflecting coordinate points on, uh, well, a coordinate plane, and we were looking at mapping diagrams, mapping notation, and just showing what coordinate points do as we reflect points over certain lines, like the y-axis, the y equals x line, the x-axis, and the y equals negative x line. So those four lines. On Friday, I ran out of time in all three of my integrated math 1 classes in having them take the notes on the mapping notation, which I wrote on your little sub plan there. Can you make sure that the students get those? And you can do some examples of reflecting points and use the patterns in the coordinate points to know where the image, the reflection point, is going to go without actually graphing. So after you go through those notes with them, this is their assignment that I made for them to work on. So I give them some different quadrilaterals or triangles. I give the pre-image point coordinates, so they need to use their notes and use the patterns to know if we're going to reflect M, for example, over the y-axis, then this point is just going to go to 2, 5, right? A is going to go to negative 2, 3, and so forth. So have them fill out the coordinate points for the image and then have them draw both the pre-image and then the image after they reflect, the coordinate points so that they can visually see that the rules are right. Okay, y equals x line and also the y equals negative x line, they need to show that line of reflection and also graph the pre-image and the image on their assignment. So I think that that's pretty much self-explanatory. So make sure that they get the notes on the notation and where the coordinate points go, and give them the worksheet. Okay, so that's integrated math 1. Okay, I made it this way, so if you're watching this video, I'm kind of separating. If you look for the black and the yellow, kind of the different sections of the podcast to talk about the different classes. So chord geometry now. Okay, Thursday, Friday, we used GeoGebra. Again, we started a unit on special quadrilaterals. Okay, so like parallelograms, um, rectangles, squares, rhombuses, trapezoids, isosceles trapezoids, and kites. So the whole special quad unit, okay, um, they had on Thursday, I gave them a list of definitions. So, like this, for instance, this is what I gave them: the definitions of each of these special quads, because they've seen these shapes before, they've heard of them, but now that we're looking at the actual definition, we use GeoGebra to construct these based off the definition here. So, Friday, the kids through Edmodo submitted a Word document that said like parallelogram, and then it screenshotted their construction of a parallelogram and then like rectangle, and then screenshot of their construction. But it made the kids focus on the actual properties and definitions of each shape. So now, what I wanted them to do on Friday also, they attempted to fill out this chart. I was just kind of curious to see what they knew and what they could do. Some students did okay. Most students were kind of lost, especially with these symbols, with angle, symbol, consecutive angles and consecutive sides. They need to know what that is. So if you can help explain that to them a little bit better. Congruent and perpendicular. And these properties have to be true for all of them, for example, like consecutive angle sum equaling 180. This is true in a trapezoid only for the consecutive angles between the parallel sides. But the other two consecutive angles, the non-parallel sides, so like for example, this trapezoid here, um, this angle, because of our parallel lines, just looking at this trapezoid, if you can see this in the video, I hope. So here's a trapezoid. These sides are parallel. Therefore, this angle M and angle P would be supplementary. N and O are supplementary, but M and N are not. Either are P and O. So those pair of consecutive angles are not. Therefore, in our chart with trapezoids, it doesn't satisfy this because we need all consecutive angles, like in all your parallelograms. Okay, you can talk subsets also if you want, like parallelograms, rectangles, rhombuses, squares. Those are parallelograms, therefore rectangles, rhombuses, squares will have the properties of parallelograms. A square is a rhombus and a rectangle, so it'll have properties of that as well. Okay, so if you want to go over that with them. To do that, I will email you this special quad tools GeoGebra app that I made, and it's just as easy as you watched me make on this podcast. Each of these custom tools up here are your special quadrilaterals. So you just click the points on GeoGebra here, and it makes the shape. And I have the definition parts shown here. So like in a kite, we have these two consecutive sides that are congruent, and they're not congruent to the other pair of consecutive sides. So you can see that there. Parallelogram, you can see opposite sides parallel. Trapezoid, you can see one pair of parallel sides. Okay. Um, so I believe with the rectangle, if you move it, you get a 90-degree angle to show up. Yeah. So now we have the rectangle here. It's a parallelogram with right angles. Okay, so, and there's a square up here also, an isosceles trapezoid. So what I would recommend for you is there is no assignment in core geometry. I would have them go through the chart, maybe even have them take a blank chart and we'll fill it out together correctly, and then they can compare, see how well they did initially. But most of them didn't really know what to do, so this is kind of news for all of them. But have them get their laptops out and um, just lead a discussion in each one of these. So maybe, clear the screen after they use a tool and investigate the properties of one parallelogram. So what I mean, for example, is let's say that they're going to work on isosceles trapezoids and check out its properties. Okay, so this, for instance, would be, there we go, an isosceles trapezoid. So when we look at diagonals, they need to use their segment tool and make diagonals so that they can check out the properties. They're obviously not perpendicular. They don't look like they're bisected, but they do look like they're congruent lengths. So we can use the tools if we want to check congruence by measuring if we want to. So just grab your length tool, click on your segments. Hey, they're the same. And it seems like no matter what our isosceles trapezoid looks like, they're always going to be the same. So then we can check out that property and fill it out in our table. Okay, so lead a discussion for the hour, going through the special quad tools and filling out the properties so that the kids get a good idea of the properties so that on Tuesday, we're going to get GeoGebra out again when I get back, and we're going to use the properties, and I might continue this on Wednesday. I'm not quite sure yet what I want to do when you come back to cover me, but we're going to use the properties and construct the shapes based off properties. The converse logic of here's the shape, what are the properties? Now we say here's a shape with these properties, therefore it is whatever, a trapezoid and whatnot. I hope that makes sense. So by the end of the day, make sure that chart's filled out properly and the kids get enough feel for diagonals, perpendicular, consecutive angles, consecutive sides, all that good stuff. Okay, so I hope that makes sense. And then the third is Math Essentials, which um, luckily for both of us, our one friend that gave us a problem is out of there, so she will not be in class. So class is actually going really well. The boys still don't do anything, and the girls are super social, but at least they get their stuff done. So I can't really complain too much about that class anymore, which is nice. But Math Essentials, what I got was from Kuda Software, just some more reflection practice for the kids. Just to get an eye. This worksheet, though, has them draw some different vertical and horizontal lines, but also they got practice the y equals negative x, y equals x line, Okay, this side here on the second sheet, write the rule. So they need to say it reflect over which, the line of reflection. So they need to know what line is getting reflected over, even though they don't see it. But they can draw it in and write the equation for it. Okay? So the kids in Math Essentials need to make sure that they have their integrated assignment done and also this one done by the end of the period. And go ahead and collect this, and I will, or you can just give them a completion grade if you want, if you have time. If not, I can do it too when I get back. Okay? Pretty easy day for you, I think. It'd be kind of fun. The geometry lecture, I'm looking forward to. I hope it goes well for you. Integrated math, again, make sure that they get the notes, they know how the patterns work, and they know how to get through the worksheet. Okay? Thanks, Adrian, man. Appreciate it, and hope everything goes well for you. Have a good one.